Okay, so this video is meant for my Concepts of Algebra 2 students. We have a quiz on Tuesday covering sections 5.1 and 5.2. This YouTube review should help you prepare for that quiz. Alright, so first, let's take a look at this problem, number 1. And we're going to graph, okay, and label the vertex and the axis symmetry. And here's our equation. Y equals 1/4 x squared minus 1. So the first thing I will do is underneath, I will write standard form, because this is in standard form. Ax squared plus bx plus c. And I will identify what a, b, and c are. A is 1/4. B, the bx term is not there, so b is 0, and c is -1. So the first thing I will do is I will find the axis symmetry. So part 1, axis of symmetry. And to do that, you have to use that memorized idea. And that memorized idea is x equals the opposite of b over 2a. That is the equation for this axis of symmetry. So we take our numbers from above. Opposite of 0 over 2 times 1/4. This is a special situation because the top is going to be 0, and it doesn't matter what the bottom is. If the top is 0, the answer is 0. So our axis of symmetry for this problem, x equals 0. To graph that, we're going to put a dotted line where x is 0, and it's going to be vertical. So it actually turns out to be the y-axis. And I'm going to label it x equals 0. There's the axis of symmetry. And there's part 1, the first thing. Okay, let's change color to orange. 2, I want to find the vertex. And I'm going to scroll down. The vertex has the same x-coordinate as what we just found, 0. Now to find the y, I have to plug 0 into the function, the x value into the function. Y equals 1/4 times 0 squared minus 1. And I'll use my handy-dandy calculator, and I'll get -1. There is my vertex, 0, -1. So I'm going to put 0, -1 on my graph. It's going to be on that axis of symmetry right there. 0, -1. And now I need to find 2 other points. That's the third step here. Get your 2 other points. And to do that, we're going to choose an x value. Now, this axis of symmetry is 0, so I want to pick 2 to the right or 2 to the left. Well, 2 to the right of 0 is 2. So I'm going to pick an x value of 2. So I choose this x value of 2, and I plug it in. Y equals 1/4, 2 squared minus 1. And I use my trusty handy-dandy calculator, and I'm going to get 0. So this is the point 2, 0. And I'm going to graph that on my graph, 2, 0. And there is the right side of this U-shaped graph. I gotta make a nice. Okay? And if we take this point and go across the axis of symmetry, because symmetry means the same on both sides, take this point right here, that is also a point, -2, 0. And there's my parabola for this function. Okay, our second problem is the same kind of problem. Graph it. It's in standard form, so right below I'm going to write what standard form is. Y equals ax squared plus bx plus c. I'm going to identify a is 3, b is -12, and c is -5. Okay? So first thing I will do is find the axis of symmetry. And to do that, I use that memorized x equals opposite of b over 2a. That is x equals the opposite of -12 over 2 times 3. Simplify the top and bottom before you do anything. This is 12 plus plus. This is 6. 12 divided by 6 is 2. There is your axis of symmetry. X equals 2. I will go where x is 2 and put a dotted vertical line through that point. There. And this is x equals 2. Okay. Now I will find my vertex. To find the vertex, I'm going to use the x value from part 1, 2. And to find the y, I will plug 2 into the original function. 3 times 2 squared minus 12 times 2 minus 5. And using my handy-dandy calculator, I get negative 17. Okay, so this is kind of a crazy one. Negative 17. So there's our vertex at 2, negative 17. And again, we have to go down 17 units. That's going to be very far down the graph, but it's no big deal. We'll just make it work. So we're going to come down here, and I'm just going to estimate where it is. So 2, negative 17. This is 6, 7. I'll just put it right here. And that's the vertex at 2, negative 17. Okay, so just estimate. It's not a big deal. Now I need my other 2 points. Now, this axis of symmetry is at 2, so let's pick 2 to the left or 2 to the right. 2 to the left would actually be 0. Let's pick an x value of 0. I like 0. And let's find the y by plugging it into the original function. 3 times 0 squared minus 12 times 0 minus 5. And we are going to get a y value of negative 5. So this is a point on the graph. 0, negative 5. 0, 1, 2, 3, 4, 5. And this is the left side of my problem. Okay? And to find the other point, just go straight across the axis of symmetry to the other side, and we get the point 4, negative 5. And there's the picture of this this quadratic function. Very good. Okay, problem 3 here, we're going to multiply these two binomials using the FOIL method. Okay, so I'm actually going to rewrite the problem down here. X plus 6, 3x minus 2. Let's go with the red first. X times 3x. 3x squared. X times 3x. The 3 comes in front. X times x is x squared. Okay, then we'll do the outer. X times negative 2. That's going to give me negative 2x. Then we will do the inner. 6 times 3x. And 6 times 3 is 18. And the x comes with. It's positive because they're both positive. And then finally we'll do the last. 6 times negative 2. And that is negative 12. There's the FOIL. Now the last thing to do is to combine your middle terms. The like terms. 3x squared, negative 2, and positive 18 is positive 16x. And the minus 12 comes down. And these two binomials multiplied together result in this trinomial. Okay, here's the fourth problem. We're going to write this equation in standard form. So just to remind you, standard form, y equals ax squared plus bx plus c. There are no parentheses, so we must get rid of these parentheses. Now, this problem, x minus 4 squared, really needs to be written like this. 2 times x minus 4 times x minus 4 minus 1. So the x minus 4 squared is really just x minus 4 times x minus 4. And we're going to do that part first. Just like we did in the problem above. First, x squared. Outer, negative 4x. Inner, negative 4x. And last, positive 16. Negative 4 times negative 4 is positive 16. And we'll combine those to get negative 8 in the inside plus 16. Now, the tricky part is this 2 has to be multiplied to that binomial product, or that x minus 4 squared. So what you get when you multiply them should go in parentheses. We're going to bring this down, and I'm going to bring the negative 1 down at the end. So y equals 2 times, that's times, and then this is minus, excuse me. And now we're going to distribute the 2. Y equals 2x squared minus 16x plus 32. This minus 1 just comes down, That's kind of confusing. Let's just put an arrow. And then we combine the 32 and the minus 1. And we get y equals 2x squared minus 16x. And 32 minus 1 is 31. And there is this equation in standard form. Okay, now let's graph this one. And this time we're working with vertex form. So remember, vertex form, y equals a x minus h squared plus k. This is vertex form. So with vertex form, we're going to identify what a, h, and k are. A is for h. Now because this is a positive 3, h is actually negative 3. Because having a negative h with this negative would create that positive. So h is negative 3 and k is negative 1. So first step, axis of symmetry. And that is x equals h. So what is that? X equals negative 3. There you go. Graph it. Go to the left 3 and put a vertical line through that. Okay. Now we need to find the vertex. Part 2. Well, the vertex is just hk. So what is our vertex here? Our vertex is negative 3, negative 1. And now we graph that. Negative 3, negative 1. And now the last part is we need our 2 other points. And this is probably the most difficult part of this process here, to get these other 2 points. Again, our axis of symmetry is at negative 3. So pick a point to the right or pick a point 2 places to the right or left. Let's go either negative 1 or negative 5. Let's go with negative 1. So I'm going to plug negative 1 into the original function for x to see what I get. And my handy dandy calculator says 15. So I'm going to attempt to put the point negative 1, 15 on my graph. Now, it's going to be way up here. Negative 1, 15. This is 6 here. That's negative 1, 15. No big deal. Who cares? And we connect it. There's the right side. So now we use symmetry to go over here. Right? If I extend my axis symmetry, use symmetry to go 2 to the left of negative 3. And that would be the point negative 5, 15. And there's the left side of my parabola. And there's how we graph in vertex form. Alright, next, we're going to tell if this function has a minimum or a maximum value, and then find the minimum or maximum value. So, when you see min or max, you should be thinking vertex. Okay? Because the vertex is that minimum point, if it opens up, or maximum point if it opens down. Okay? So to determine if it opens up or down, to determine if we have a min or max, we look at A. This is standard form, y equals ax squared plus bx plus c. A is 2, B is 8, and C is 7. So our A value is 2. 2 is positive, which means our parabola opens up. Which means if it opens up, look at the U, if it opens up, we have a minimum value. Okay? So now how do we find that minimum? Well, it's the y of the vertex. So I'm looking for the y of the vertex. So I will find the vertex. So first, to find the vertex, I need the x. So I'm looking for the vertex. Now, to get the x, remember we used that memorized idea. X equals opposite of b over 2a. That's the opposite of 8 over 2 times 2. That's the opposite of 8, or negative 8 over 4, which is negative 2. There is the x of the vertex. Now, that is not the value I'm looking for. That's not the minimum. That's just the x. But to find the minimum, the y, I need to then plug that x into the original function. 2 times negative 2 squared plus 8 times negative 2 plus 7. And my handy calculator tells me that y is negative 1. And there is the y, which is the minimum value. So in this function, there is a minimum value of -1. A minimum value of -1. And that's all you need to do. Minimum, maximum, find the vertex. One more problem. Okay, so we have a red kangaroo, and its jump is modeled by this formula, and we need to fix this formula. Good thing I caught it. This should say x squared. Okay, so y equals -0.03x squared plus 0.84x plus 0.12, where x is the horizontal distance in feet and y is the height in feet. And the question is, what is the maximum height of the kangaroo's jump? So what they want to know is, how far is this? Right? That's the height. And the height is the y of the vertex. This is the vertex, x, comma, y. We want the height, which is the y. Remember, if you see this word maximum, you need to think of vertex. And the height is just the y. That's what the problem tells us right here. Y is the height. So what I'm going to do is I'm going to write this equation down. Okay, and it says y equals -0.03x squared plus 0.84x plus 0.12. I cannot wait to see all your kangaroos. I better see kangaroos on your papers. And I'm going to put the standard form, which it is in below, ax squared plus bx plus c. And I'm going to identify what a, b, and c are with a little bit of space because they're decimals. A is -0.03. B is 0.84. C is 0.12. So I have what my A, B, and C are. Now I'm going to scoot up just a little bit. Now I need to find the vertex. To find the x, remember we used that memorized opposite of b over 2a. That's the opposite of 0.84 over 2 times -0.03. And make sure you simplify the top and bottom first. So this is -0.84. This is -0.06. And now let's divide. And our calculator tells us, hey, look at that. We get a nice number of 14. Now that is not the answer. That is the x. Remember, if we look up at this picture, we want the y that goes with it. We want the height. The height. So I need the y. Well, to find y, you plug x into the original function, which was -0.03 times x squared plus 0.84 times x plus 0.12. And my handy-dandy calculator tells me that this comes out to be 6. And this is the y of the vertex. That is how high that kangaroo jumps. So what is the maximum height? The max height is 6 feet. Okay? So hopefully this video helps you, and we'll see you on Tuesday for your quiz. Enjoy the long weekend.